In this problem, it's given here that the arithmetic mean of two numbers b and c is a. Also, g1 and g2 are two geometric means that has been inserted between these two numbers b and c. Now we need to show that g1 cube plus g2 cube, that's equals to 2 times a, b, c. So let's begin. So we have here, so let's write it down, whatever is provided to us, the arithmetic mean of b and c. So that's equals to a. The arithmetic mean of b and c, that's also defined as b plus c divided by 2. So that will be equals to a. Or we can say b plus c equals to 2 times a. So let this be equation number 1. Then it's given that g1 and g2 are two geometric means that has been inserted between b and c. So that means b followed by g1, g2 and c. So these four numbers are in geometric progression. Now we can find out the common ratio. The common ratio is defined as the last term, which is c divided by the first term, raised to the power of 1 over n plus 1. So here n represents the number of arithmetic means. So here, since we have two arithmetic means, g1 and g2, so n value is going to be equals to 2. So we have c over b whole raised to the power of 1 over 2 plus 1, so that's going to be 3. So let this be equation number 2. Now that we have the value of a common ratio, we can also obtain the value of g1 and g2. So let's do that. So the value of g1 will be, you take the previous term, which is b, and multiply it to the common ratio, that is r. Now that means we have b multiplied to c over b whole raised to the power of 1/3, which will be b times c raised to the power of 1/3 divided by b raised to the power of 1/3. So b, we're combining the two b's in both the numerator and the denominator. So b will be raised to the power of 1 minus 1 over 3 times c raised to the power of 1 over 3. So we get b raised to the power of 2/3 times c raised to the power of 1/3. This is going to be the value of g1. Then we can also find out the value of g2. The g2 will be equals to the previous term, which is g1 multiplied to the common ratio r. Fine. So g1 we already obtained. This value is b raised to the power of 2/3 times c raised to the power of 1/3 multiplied to the common ratio, which is c over b raised to the power of 1/3. So let's find out this value. So b raised to the power of 2/3 times c raised to the power of 1/3 times c raised to the power of 1/3 divided by b raised to the power of 1/3, which will become b raised to the power of 2/3 minus 1/3 multiplied to c raised to the power of 1/3 plus 1/3. We're using the laws of indices here. So therefore g2 will then becomes b raised to the power of 1 over 3 times c raised to the power of 2/3. So we have obtained the value of g1 and g2. So let's start from the left hand side of our equation. I have on the left hand side g1 cube plus g2 cube. So g1, that's b raised to the power of 2/3 times c raised to the power of 1/3 whole raised to the power of 3, plus the value of g2 will be b raised to the power of 1/3 times c raised to the power of 2/3 whole raised to the power of 3, which is going to give us now b squared times c plus, and this will be b times c squared, which will be equals to, so if we take b times c as the common factor, so we have b plus c. So we have already defined in equation number 1, the value of b plus c is 2a. So we can replace that value of b plus c with 2a. We're going to get finally 2a times b times c, and this is the expression on the right hand side. Hence we have successfully showed that g1 cube plus g2 cube, this is equals to 2 times a, b, c,